So let's look at a particular question as already seen on the board. The diagram below, talking about this, represents the velocity time graph of a body in motion. If the total distance is 195, that means the total distance the body covers is 195 meters. Calculate the acceleration of the body along the path OP. We need to calculate the acceleration of the body along this path OP, right? There are different parts, OP, PQ, QR, and the RS, and so on and so forth, okay? Now, to do this, we need to first of all calculate the velocity of the body. The velocity of the body is V meter per second, is not given. So the first thing we need to do here is to calculate the velocity of the body before we can now say calculate the acceleration along the path OP. Alright? And we have options. Option A is 1.0 meter per second squared. Option B is 2.5 meter per second squared. Option C is 7.8 meter per second squared. And finally, option D is 9.3 meter per second squared. We don't really know the suitable option to this question until we solve it. So let's go into solving now. So the first thing we need to do is we write our solution and then analyze the graph. This is a velocity time graph. Quite obvious and quite clear to that. Now what we need to do is we consider this trapezoid shape. Look at this. We consider this trapezoid shape. Alright? And then use the formula for finding the area of a trapezoid or trapezium, okay? We consider this trapezoid shape and then use the formula for calculating the area of a trapezium to find the total distance. But funny enough, the total distance has been given. I repeat, funny enough, the total distance has been given as 195 meters. Okay, this has been given. So what do we do? Let's state first of all the area, the formula for calculating the area of a trapezium, right? Formula for the area of a trapezium, in brackets, trapezium. That's what we need to do, okay? So let's look at that. That should be half brackets, the parallel lines. We have two parallel lines here, OR and then PQ, right? Have the sum of the parallel lines and then multiply by the vertical height. The sum of the parallel lines OR. That's the first thing. OR plus the sum. That's been a sum. Then PQ. PQ is given there, and bracket close. Then the height is PT. PT represents the height, or QX, any of the two. So we use PT, okay? The next thing we are going to do is to substitute. We substitute at this point for OR is 21, okay? 21. For PQ, this is PQ, that's the difference between 6 and 11, is 5, all right? And then the height times the height, PT. PT is the one not given. That means is velocity measured in meter per second. That's what we're looking for. We must look for this. We must find this for us to be able to calculate the acceleration along this path OP. So what do we do? All equal to, with this, we now equate it to 95, being the total distance given. So we have half bracket open, okay? 21, look at this. 21 plus 5. We can as well do it here, but instead of squeezing things here, let's just move on to the side. 21 plus 5 is 26. And we have just 26 bracket open and close, V M X all equal to 195. Okay, that's it. So we can go 2 divide itself is 1, 2 divide 26 is 13. That's it. So we have 13, and our bracket we have V meter per second. That's what we're looking for, 195. Alright? What next? We need to find the value of the velocity of the body in motion by dividing through using 13. So we can say 13 VMS, right? All over 13 this side is equal to 195 all over 13. Good. So this will take care of this. And then this is 1, this cancel this becomes 15. Therefore, Vmx is equal to 15 meter per second. Now we have succeeded. We have succeeded in finding the velocity of the moving body or the body in motion. We cannot find the acceleration along the path, or P. We can find acceleration now. Acceleration now can be found using that. We can now say acceleration A in brackets, okay, is now V that has been found, all right, all over time taking that along that path. So along that path OP is equal to V, which we have found, all right, already, over time taking. So what is V? V is the velocity of the body in motion, and it's been found to be 15 meters per second. So we have 15 meters per second all over. Time there is 6. Time there is 6. Okay? And this will give us 2.50 seconds. 50 meters per second, okay? So acceleration along OP is giving us 2.5 meters per second squared. Solved. Check this. That is it. 2.5 meters per second squared should be the acceleration along this place, this path. A is equal to 2.5, all right? If there's need for that. So that is it. We have just answered this question, and it's very simple. But if you think the steps are not clear, what you need to do is to comment it in the comments section or box. Give me some thumbs up, give me some comments, and then subscribe. Remember to share with your students. This content is for educative purpose. Share with your students, share with your fans, share with your networks, and at the same time, don't forget, I want to read your comments. I want to read your comments in the area you don't like, or in the area that you like about this. I want to read your comments. And with that, I will not know what moderations I will do next one. See you there in my next class, okay? Thank you so much for watching.